guys. Let's get started. First of all, we'll just recap whatever we did in our previous class. We introduced structure analysis, the need for structure analysis. I told you that mainly structure analysis is necessary to work out the applied forces. Excuse me, can you have a bit silence? Thank you. Okay, so structure analysis is actually structure analysis involves lots of methods for determining forces, unknown forces in a structure. So what are the unknown forces? You have got the applied load on a structure, okay, and you are necessarily trying to find out your reactions, unknown reactions. And if you know the applied load and the unknown reaction, then you can find out, like, you know, what is the stress path, how the forces are flowing into your supports and that sort of thing. So that, but before starting to analyze, before starting to design any structure, okay, you need to know what sort of forces are running in your structure, okay, and what sort of force and what the reactions are. So that's what the structure analysis do for us. We have bending moment. So once you have got the reactions found, then you can work out your bending moment diagrams, your shear force diagrams, and from there onwards, I mean, like the other analysis starts. So I told you that the difference between structure analysis and the mechanics of solid was that the structure analysis, in structure analysis, you are trying to find out your unknown forces in a structure. Unknown forces are essentially the reactions. In the case, once you find that out, then based on the methods you read in your MOS, mechanics of solid, you use those techniques to find out stresses, okay? And once you know the stresses in the structure, then after that you can design a structure. I mean, by design we mean that you can come up with a certain material, what sort of material you want to use. You can come up with a geometry, with a cross section, with the dimensions, everything, okay? So that's what the ultimate aim is, isn't it? That you have the applied loading and you want to find a structure, a suitable component, a structural component which is able to transfer that loading into the supports. Okay, so one thing you must appreciate, that in structural engineering you have got loads in different places. Okay, that load might be on ground, that load might be in the air, and you are trying to bring the effect of that load to the ground. Okay, how can you ensure the load stay in the air? Obviously you have to provide some components, structural components, and those components should bring the load to the ground. Like, what do I mean by that? Like, for example, we have got a class on top of this room, isn't it? There is another class on top of this room, and you have got students over there. So if you want, and those students are like loads, isn't it? You have got loads in the form of students who are moving, so these are live loads, and then in addition to that you have got dead loads. So dead load, like, you know, the desks, you have got desks, or even the slab, self-weight of slab. You have got chairs, you have got, I mean, like, whatever you can think of, any equipment. So those loads have to be brought to the ground. Okay, and how do you do that? You provide some additional components to the structure, structure components, and those components then transfer the load to the ground. So, what I was saying is that we have to, so you have to find out the design of those components. Okay, by design we mean that you have to find out the dimension of those components, and for that you must carry out structure analysis first, which means, like, you must find out the support reactions, and you should draw the shear force bending moment diagrams. And after that, the second part is that you find out the stresses in the structures. Okay, different types of stresses and strains, and once you do that, based on that, you can easily find out your area of cross sections, your dimensions, your geometry, and you can come up with certain material also. I mean, like, you know what sort of material is good enough to take that type of loading. Okay, so that's what we did in our previous class. Now, after that, we moved on to different types of structure components. Okay, so what are structure components? Structure components are different types of objects which do the job for you. Okay, this is in your, you have got a structure toolbox, and you have got different types of components, like you have got beams, columns, frames, you have got what else, trusses, and a different type of girders, and I mean, like, you know, there is a variety of structures. And you, being a structure engineer, you must know what is an appropriate component which will transfer the load for you. So now, for example, you want a class on top of this room, okay? And this class, I've told you that this class would have students sitting there. So you've got live load, it has got desk, it has got board, it might have some equipment, and so that is a sort of a dead load. Okay, and then in addition to that, so you have to now provide some structure component which can bring the load down to the ground. I mean, like, obviously you can't have them hanging in the air. You have to provide some components to bring the load of these objects to the ground. So what you do is you raise the walls. Okay, so you raise the walls, which are the vertical components, and then on the top of wall you place a slab. Okay, so that slab gives you, that's a structure component. That component actually takes the load, whatever is on the top, and bring it down to the ground. Okay, how? That slab transfers the load to the walls, and from the walls it comes down to the ground. So these are all structure component. Walls are structure component, and what do you call it? The slab is structure component. Okay, and then after that, you have got footings. Okay, you have to provide foundation for the walls. These are also structure components. So, so this is important, that you must appreciate what is the appropriate component which you can provide in order to transfer the load. And by appropriate, I mean that it should be economical. Okay, it should do the job for you. Okay, it should be efficient, and so on and so forth. So, so in structure analysis, there are three things which you will always come across. You will accept or reject a certain component based on three important parameters. The first parameter is strength. Strength means that how much strong that is, that the structure doesn't break. Yes, strength. The second component is stiffness. The structure doesn't deform too much, or the component doesn't deform excessively. Okay, a chewing gum, take example of a chewing gum, you apply certain load and it keeps on deforming. You don't want that. So that is stiffness. It should be stiff enough not to deform excessively. And the third one is, so strength, stiffness, and third one is stability. Stability means the structure doesn't collapse. Okay, so these are the three important parameters which you must consider in the case of structures. If any component which takes these, which is able to comply with these three parameters, or which is able to sustain the applied loading, it must ensure that it is strong enough, it must ensure that it is stable enough, and it must ensure that it is stiff enough. So these are the three important things. Okay, so now, for example, just take the example of this room. Okay, in this room we said that in the previous class that we have got the height. Height is around about 12 feet. Okay, and you have the width. The width is a smaller dimension, and the length is normally the longer dimension. Okay, so the width we said is around about say twice of this, so 24, and we said the length is approximately say 30. Okay, but Now, is this, so for example, if you want to provide a slab, okay, is this 24 by 20 feet length good enough to ensure that this, the slab is strong, it is stiff, and it is stable? That is something which you have to work out. Sometime by using your engineering judgment, and by judgment I mean, like, you know, using the common sense, the engineering sense which you will develop with time, and also through calculations. Okay, you must ensure that you must be able to work out whether something is is passing or failing. By failing, I mean that these three parameters are not satisfied. Okay, the strength, stiffness, and stability, these are violated somewhere. So you can see that someone has provided a frame over here. Okay, can you see there is a frame in the middle?
Yes, sir.
This tells me that why do you think this frame is provided in this room? Yes, because obviously, I mean, like, it's not only stability, we don't know, but obviously strength, stiffness, stability, something would have been violated. That's why they provided this frame. So in other words, if they had not provided the frame, what would have happened? Maybe the slab would have failed, either in strength, okay, either in stiffness. So in other words, so in strength means, like, you know, you would have a completely crushing, okay, so breaking, rupture of the slab, okay. In the case of stiffness, I mean excessive deformation, to an extent that you have you could visually see the slab hanging, okay, like a chain. So that could have been the case. And number three is stability, which means, like, you know, the slab might have, this overhanging might have overloaded the support structure, and the whole structure would have collapsed. So for example, I give you another example of the same slab. For example, if I remove one of the wall of this room, okay, that wall, if that is completely removed, what will happen? The load, the applied load, which is from the top, would be then taken by the three walls, because we have removed one of the walls, okay. And if we, so it is possible that those three walls are overloaded and they are not able to take the load, okay, and as a result the whole structure collapsed. These the three walls just collapse, and as a result the whole system falls down. So you have got the collapse of a structure. So the important thing is, so by collapse I mean that normally what happens is that one of the critical component is accidentally removed, and as a result the other supports are overloaded, okay, and what happens, the structure, the other supports are not able to sustain the load, and the structure collapses, okay. So if you have critical structures, like nuclear power plants, like or other structures of strategic interest, okay, so those are normally constructed in such a way, those are designed in such a way that they can overcome this progressive collapse. And how would they overcome? They do lots of tests on it, like, you know, for example, first of all, the designer he writes down, or he the main structure, the critical components, okay. So the designer gets narrate all the critical components. So the critical components in your room, in this one, are which one? What are the critical? The walls. The critical components mean, what are the critical components? If you remove them, the whole structure can collapse, okay. So if you remove the wall, the whole structure can collapse. Okay, but this false ceiling is not a critical component. Okay, this is a structure. It's a secondary structure or tertiary structure. Okay, so this is not. So first of all, a designer, okay, narrate all the critical components, and then he sees that which, if he or she removes any critical component, what will happen to that structure? The other supports are overloaded. Then he makes sure that the other supports are able to take that excessive load also. So in that way, the other structures, the other supports are not overloaded. In other words, if you write from the beginning, if this is a strategic structure, okay, and the strategic structures are always susceptible to, say, terrorist attacks, or okay, so what people do is they remove the critical components. Okay, so for example, if I have to design this room, the wall which is closest to the outside, that has the probability of being removed, because, like, for example, you can have a terrorist attack on this, or maybe a van ramming into it and just blowing it up. So what can we do? So we can remove this wall which is closest to the road, okay, or which is closest to the outside area, and then you remove that, and then after that you check how much would be the load running into the rest of the walls, and you make sure that the rest of the walls are able to take that load. So that's how you ensure that the structure doesn't collapse. So that's a collapse. So stiffness means, I give you the example of a stiffness, that for example, if you have got a structure which is, say, if you have got a slab which is, say, very long, okay, very long slab, so that long slab is susceptible to bending, isn't it? And it can have excessive deformation. What do I mean? Like, for example, if you have a very long slab, it can bend like this. So this means, like, this is not stiff enough. Yeah. So what do? You provide some additional beams or columns so that to make it stronger, so that it doesn't bend. Okay. So that's what. So you increase the stiffness of it. Yeah. So that's what. And the other parameter is your strength. Strength means that your structure, the material which you are going to use, that is strong enough to take the applied load and it doesn't crush. Okay, so you have seen in the labs, you have tested cubes, you have tested cylinders, haven't you? No, sir. Okay, not yet, but I mean, like, you will do that in your reinforced concrete or in your materials. You will test them, and you will see that when you apply the load, what happens? You keep on increasing the load on the cube or cylinder. A stage comes when you are not able to apply any more load. Why? Because the cube collapses. Okay, or sorry, it crushes. Okay, so all the bonding, everything, that is lost, and the structure and the cube or a cylinder is not able to take the load. So that is your strength, stiffness, and stability, and you have to ensure that the structure is able to sustain, is able to ensure these three parameters. Then you have principle of, we did principle of superposition. Okay, what did we say about principle of superposition? What was principle of superposition? Yeah, I mean, the principle of superposition tells you that if you have any unknown parameter in a structure, okay, any unknown parameter, if you have a structure which is subjected to many loads, okay, and you're trying to find out any unknown parameters, say that can be shear, that can be moment, that can be reactions, that can be anything like that, okay, and so if that unknown parameter under the combined effect of all loading is equal to the sum of the loading of the individual loads. Okay, so if you have a beam or a frame which is subject to, like, for example, if I have a beam which is subject to many loads, I can have it divided into several beams of the same length and same supports, and these loads, I can have these loads applied independently, okay, and any unknown effect which I'm after, I can easily calculate that, okay. So unknown effect, by unknown effect I mean we can have shear, we can have moments, we can have, you have got shear moments over here, yeah, or you can have deflections. So anything you are after, you can have even reactions, okay. So anything you want to find out, okay, so for a beam which is subjected to multiple loading, okay, that can be, okay, so that can be divided into a series of beams or series of structures under independent loads, okay, and then you algebraically sum up and find out that effect. Okay, so if I'm interested in finding out the deflection over here, the overall deflection would be equal to sum of the deflection of the independent loads. Okay, or if I'm interested in finding out shear or bending moment of this structure which is subjected to all the loads, I can have it decomposed into these beams and then independently find out the moments and add them up, and I can find out the final moment. Okay, so any question? Any question about this? Any question? Yeah. Okay. So now we'll move towards finding out reactions. Okay. Finding out reactions. So what do you think? How can we find out reactions of any structure? What are those tools available to us? Yeah. The important thing in case of finding any reaction, okay, is equilibrium. Okay, so if you have any structure which is subjected to any sort of loading, you can use the equilibrium equations to find out the reactions. And the equilibrium equations are normally the summation of forces must be equal to 0 and summation of moment must be equal to 0. Okay, so it is important that first of all, you establish whether you will treat a structural component as a 2D, as a 1D, or as a 3D. As a 1D, 2D, or 3D. What do we mean by that? Yeah. What we mean by this is that normally the structures are in a 3D space, isn't it? They are in a space. So we, for our convenience, we make it in a two-dimensional space. Okay. So we assume that the structure is in a two-dimensional, and how does that help us? That reduces the number of equations for us. Okay. So the number of equilibrium equations in case of a 3D are how many? 6. Are 6. Okay, because you have got forces in 3 direction and moment in 3 direction. If you assume that it's 2D, then it's the equations are reduced to 3. Summation of fx, fy, and summation of moment. Okay, so but you can have 3 or 4. I agree. How can we have 4 equations? For example, if we have a beam and we assume that the dimensions are, we have got 2 dimensions. Yeah, we have got 2 dimensions and we have got a beam. So the equations normally would be, imagine this is our A and this is point B. So the available equations are summation of fx must be equal to 0, summation of fy must be equal to 0, and summation of moment about z must be equal to 0. These are the 3 fundamental equations. However, if you have got a torsion also in the structure, so you would have another moment equation which is summation of mx must be equal to 0. So this is for torsion, but torsion case, in this course we won't be doing that. Okay, so we will restrict ourselves only to summation of fx, summation of fy, and summation of mz. And this is, the mz is actually your flexure moment, isn't it? The moment in z is actually called flexure moment also. Or in other words, the moment mz about certain point will cause flexure stresses. So these are the 3 equations which have to be satisfied in order to get your reactions. What will happen if you have got a structure which looks like this? This is indeterminate. Why is this indeterminate? Yeah, so what the important thing is that you have to see whether the number of unknown reactions, whether they are equal to the available equilibrium equations, whether they are less or whether they are more. It's very important that you work that out correctly. Okay, so that determines, so if your number of available equations are equal to number of unknowns, then number of unknown reactions, okay, then those type of structures are called determinate structures. So those structures have got no redundancy. Okay, what do we mean by redundancy? In other words, if that type of structure, for example, we have got a simply supported beam, okay, simply supported beam under any set of loading, yeah, this is a determinate structure, okay. You can find out the reactions based on the available equation, okay, but this structure has got no redundancy. And what do I mean by redundancy? If for any reason any of the support is failed, okay, is unable to transfer the load, then what happens? The whole structure will collapse, isn't it? Yes. If you remove anything. So, however, How about a structure like this? This is how many? This one has got 2 reactions. This one has got now in this type of structure,